In this problem, we're told that IQ scores were obtained for 20 randomly selected sets of siblings. The 20 pairs of measurements yield various statistics, and we have the regression equation, y hat equals negative 1.08 plus 1.03x, where x is the IQ score of the younger child. So we want to find the best predicted value of, really should be y and not y hat, but the best predicted value of y given that the younger child has an IQ of 103. And we're going to use a significance level of 0.05. So what we have to do is look at our value of the correlation coefficient, and we decide where does it fall on our number line. So we've got a number line here from -1 to 1, and our correlation coefficient is 0.936. And then what we want to do is look up in the table to see what the critical R value is. So this is our correlation coefficient from the data set, and then we'll look at our table. And we had 20 pairs of values, and our significance level is 0.05. So I look up 20, and I'm looking at the value for alpha equals 0.05, and that gives me 0.444. So that's what I'm going to mark on my number line. I have a negative 0.444 and a positive 0.444. And then I'll look at where that the correlation coefficient is located, and that is here. So, what does this tell me in terms of how I find the best predicted value for y? Well, when we have this number line, what we know, what the critical R values indicate is that if we get a value between those two critical R values, then we want to use the mean of the y values because there's little or no relationship. If we get a value that is either greater than the positive critical value or lower than the negative critical value, that's where I use the regression equation. So I'm going to use y hat in those cases. And because our value is falling within that high section, close to +1, so that indicates a positive linear relationship, and I want to use y hat. I'm going to use the equation. So, my equation is y hat equals -1.08 plus 1.03 times x, and our x value is this value, 103. So when we calculate this, we get 105.01. And that's my best predicted value for y in this case, because we can use that regression equation because there is a strong linear relationship. So the line is a good representation of what's going on with this data set. Now let's look at a case that is different from this. Okay, so in this problem, it says to use the time and tip data. So time and tip from the table below that includes data from New York City taxi rides. And we want to find the best predicted tip for a ride that takes 30 minutes. So that means that time is my predictor value X. So these values go into list 1. They are the X values for this problem. And that means that the tips are going to go into list 2, and those are the Y values. So I went ahead and did that. And you can see that those values are in the lists. So I went to stat, write that here, stat, and then we choose number 1, which is edit. And you can type those values into list 1 and list 2. So once you have that data in list 1 and list 2, then I'm going to do linreg A plus BX. So to get to this screen, again, I click on stat, and then I go over to the calc window. So I use my right arrow to get to there. And then I'm going to choose number 8, which is linreg A plus BX. And so when I do this, I put L1 for my X list and L2 for my Y list, and I can skip the rest of it and just go down to calculate, and that will give me my regression equation and the correlation coefficient. So we need both of those pieces of information. And here are my results. So I have my regression equation, and the value of A is 0.909099, so on. And the value of B is 0.0549, and so on for that. So we round those values as needed, and we put that in for our regression equation. So we've got that value. Now it says, what's the best predicted tip for a ride that takes 30 minutes? And in this problem, we are not going to use that regression equation. And the reason why is the correlation coefficient is very small. So in this problem, they don't give you the table, but what I can do is say, well, this value is falling down here, 0.342, and this would be in that middle area where we want to use the mean of the Y values, not this area where we use the regression equation. So I want to find the mean of the Y values, and that's why this problem is totally different from the last one. So how do I find the mean of the Y values? Well, I've got the Y values in L2. So I'm going to go into one variable stats and find the mean for the values in list 2. And so here, I know it says X bar, but this is really Y bar because it's the values from list 2. So we get 1.75375, and so that rounds to 1.75, and that's how we get that value for the best predicted tip, because we can't use the line. It doesn't give a good representation of the data. So we just use Y bar, which is probably not that great either, to be honest, but it's the best that we can use there. So that's why we get such a strange value there for that best predicted tip. And then it turns out that that is very different from the actual tip of $4.70. Okay, so that is what we got in that problem. That's how we do that. All right.